Hi, Gagan here, and in this video we'll be looking at how to perform a simple word count example in the Hadoop MapReduce framework using Hortonworks Sandbox VM. So let me go through the things we will need for this. Any hypervisor software like VMware or VirtualBox with the Hortonworks Sandbox VM installed. Any IDE of your choice like VS Code or Eclipse. So let's say we need to come up with a way of counting the number of votes that each candidate got across all different polling booths after an election. So in general, the polling booths are present in different locations. And whenever a voter casts his vote to a certain candidate, we take a text file and append the name of the candidate separated by a space or a new line character. So let's say if the voter 1 casts a vote to candidate A, we append A to the file. And if the second voter casts a vote to candidate B, we append B to the file with a space and so on. So this process goes on for all the voters are done voting. So once this is done, this file would be placed in the Hadoop file system, and for each location, we have one file, and all these files across the HDFS would be the input to our program. So our job is to count all the votes that each candidate got, and based on the highest count, we will decide a winner for the election. So for this, we need to perform the count program in a distributed fashion, taking the program to the node, or in this case to each booth, which is what the mapper part of the function does. And then we need to apply the aggregate sum function for all the counts across all the booths, which is the reduce part of the program. So let's quickly jump into the editor and look at how the program works. So let's say we have an input file that has multiple lines. So in our case, the input file would be the name of the candidates separated by spaces, and in this scenario we have multiple lines. So the first job we need to do is split the input file based on a certain logic. So here we're splitting based on the new line character, or in our case we are splitting it by the space. And let's talk about what it does in the map phase. So in map phase, the input data is divided into chunks, and each chunk is processed by a mapper. So the mapper processes each chunks and outputs the intermediate key value pairs, which is the key where the key is a word. In this case, they have deer, peer, and river. These are the keys, and it adds a value 1 to this. And in our case, these would be, let's say, candidate A, candidate B, candidate C with count 1. And let's look at the shuffling phase. So this is called sort and shuffle, and this is taken care by the Hadoop MapReduce framework itself, where it basically what it does is it reorders based on the keys. So we have deer, so all the deers will be grouped as one. The bears will be grouped as one, and all the rivers and cars will be grouped separately. So this internal process is taken care by the Hadoop framework. And after it is done with this sort and shuffle phase, it goes on to the reduce phase. So in this phase, the intermediate key value pairs generated by the mapper are sorted and combined by a reducer. So in this case, as you can see, this bear one is basically we are applying an aggregation function on this, on the values, not on the keys. So the keys remain the same. So we just take for each key, we aggregate using a sum function here. So the bears, we have the count 2. For cars 3, we have deer 3. So in our example, this would be candidate A, and we'll sum up all the votes. So we'll get the count of votes that the candidate A has got. So that is the reduce phase. So once the reduce phase completes itself, then it goes to the final result, where we basically club all these outputs and have a final output. So in Hadoop, this MapReduce process is distributed across multiple nodes in a cluster, allowing for faster processing of large volumes of data. So each node runs a mapper or a reducer process, and it has a portion of the actual data. So the final output of the reducer is sorted in the Hadoop distributed file system in this fashion. So as you can see, I have already created a project in Eclipse called Utopia Vote Count, and under Utopia Vote Count, we have a package called Vote Count, which has these three classes. So one, uh, the first one is the Vote Count Mapper function, the reducer, and the application that basically has the main class. So let's try to understand each of the programs. As you can see in the word count mapper function, we have the int writable one. So this is what we'll be doing in the first phase after we split it. So as you can see, this map function, it takes a key value, and this is the output, the context. So we split it based on the spaces, and then we append one to each of the words. So this will be the output that we're gonna write. So once that is done, we go to the reducer, in which basically it takes the key and int writable values and the context output that we received, and we start with initializing the word count to 0, and for every iterable values that we have, we are basically summing up those values into this variable called word count. So once that is done, we just output dot write with each key and its value. As we can see, this is the output of the reducer. We have the key and the value that is basically after it's done aggregating. And let's go to the main class. So here we can see we have certain imports that we need to do because we are running this program in the Hadoop framework. So one thing we need to make sure is that we have these libraries that are referenced, that are external jars basically, that we need to add it into the program. So three main jars I would say we would require is the client core and the client job client, and also commons. So yeah, this is commons. So basically, once you have these main things, we can start executing the program. And I would say with each error that you get, try to identify what kind of jar it says it's missing and download that jar and add it as an external jar here. So once you're done with that, you can, let's just look into what the program is doing. So we have the main function. So this is where the program starts. So we're having a interest tool runner dot run. So this basically assigns a new configuration and it creates a new application based on our public class, which is the word count application. And we have this run function. Basically, this is the run function that is called in the tool runner dot run. So in that we are setting up the job parameters that we require. So we get a new instance based on this configuration. We set the output key class, we set the output value class to iterable, and we need to set what are our mapper functions and reducer functions. So these two lines do that job. And we also need to set the format of the input, so for that, and also the format of the output. So these two lines take care of that job. And next thing is we need to make sure that we pass the input folder and the output folder as parameters. So for that we need to give command line inputs to the program. So we need to specify that in arg0 is where we have the first input, which is the input folder, which contains the what you call the input, which is the text files from each of the booths, and the output path we would specify in the args1. So basically, after it reads all the data from input and does all these mapper reducer functions, so it needs a location where it needs to produce the output. So this basically is the location where we specify for the output to be produced. So after we are done with that, we'll just call this job dot set jar by class and pass the word count application as the function. The final step we need to do is just submit this job. So this is basically what the main function does. So as you can see, if we run this program now, it should give us the exception error because the condition is it requires two arguments, so we don't have it. So this basically indicates that your program is running well, and this needs to be executed in a MapReduce fashion in order to make sure that we do not pass this if argument and these statements to run. So let's quickly jump into the Sandbox VM and look at how we can run this job. So once our program is running without any errors, we can go ahead and create the jar file. So to do that, we can right click on the name of the project and click on export. So under Java, we'll be able to see an option called the runnable jar file. We'll select that and click on next, and we'll select the launch configuration as the name of the application and the name of the project. So word count application is your public class, and Utopia word count is the name of the project, and this is where our jar file will be located. And make sure that the first option is selected, that is extract required libraries into the generated jar, because we need to have those external jar files as well. So once we click on finish, it will create a jar file at this location. So I have already created that jar file, and after you're done with creating the jar file, we can go back to our VM. So I have already started up my VM, and it's currently being hosted in the local host. So I'm using VMware for this. So the welcome screen should be at this local host. So let's go to the local host, and yeah, so here we have the Hortonworks Sandbox VM running. So click on the Ambari link and log into the Raj underscore OPS using this username, or we can log in using the admin credentials as well. So I'm currently logged in as an admin, and once we log in, we are greeted with the dashboard. Make sure that all the services are running. Wait for a few moments, and it should turn from red to green. So click on the files view that is beside the admin, and we'll be taken to the Hadoop file system. So this is our HDFS, and these are the directories that are present. So I have chosen to go with this TMP directory, or we can just create a new directory as well. So under /TMP, I have created this word count input directory that has the input files. So as you can see, we have two input files right now from two different booths. So once you're done setting up the input directory along with the input files, you can upload the jar file into the HDFS. So one thing we can do is we can either directly go to this command shell interface. So this command interface and login as admin or any other user, and using VI we can start creating the file, or we can just directly write the program into the local file system using the VI editor. Or we can, the other way around is what I did is basically I uploaded the jar file to the HDFS, and after uploading it I copied it into the local file system. So so generally the program that is supposed to run stays in the local file system, and your input and output folders are present in the HDFS file system. So in order to copy that jar file to the local file system, we can use this command, which is hadoop fs copy to local, and this would be the path to your jar file, and this is where you want your jar file to be copied to. So you can use this command. So that is what I did. So if I quickly check ls/tmp, so under tmp directory, so we have this utopia word count.jar, and as you can see I also have the word count input. So this is from a previous run, so I think it still shows up. So let's look at how we can execute it. So once you're done setting up the input folder, your jar file is present in your local file system, you can start submitting the job. So okay, so yeah, so we'll go and use this command. So hadoop jar, so the location of your jar file, and the input directory path and the output. So this one is what is created dynamically, so I can say output 2, and let's hit enter. It does take a few moments. So yeah, so it has created the job for us, and it has submitted the job. So it shows number of splits to total input paths to process. We had two different input paths to process, and this is the job ID. So let's go to the Hadoop file system, and let's check whether the output directory has been created or not. Put count output 2 under TMP. Yeah. So there we have it. So it just needs to refresh. So I think the job is still running here. So that's why it shows temporary. So we'll just wait a few more moments. So it's been a few minutes, and let's check back on the word count output 2 directory. And as you can see, there's a success message, which basically tells us that our program ran successfully. And this should be our output file. Let's open that. And there we go. We have the counts for each of the candidates, and there seems to be a tie between Gigi and Jinjin, and we'll let them decide who is the winner. So that's basically how we can perform a distributed processing across different nodes in a Hadoop ecosystem using the Hortonworks Sandbox VM and using the MapReduce framework. So I hope that was clear. Thank you.